Okay, third counting technique is known as a combination. Let's say, just like the permutation, we have one group of 10 balls, and we pull out 3 balls from that bin. However, what if we consider the number 572 and just rearranging it, 725? What if we don't count them as different outcomes, we count them as the same outcome? In that situation, we would call it a combination. So in a combination, you're selecting many items from one group of items. However, the order of the outcome does not make it a different outcome. So for example, if I had 10 balls and taking 3 at a time, that would be a combination of 10 things taken 3 at a time. I would use this formula, and I would do 10 factorial divided by 3 factorial times 10 minus 3 factorial. So 10 factorial all over 3 times 3 factorial times 7 factorial. And what you have to do is take 10 factorial and make it that, divide it by 3 times 2 times 1 times 7 times 6. So that's your numerator, that's your denominator. You end up with 120 different outcomes. So those are the 3 counting techniques. The difficulty is figuring out which counting technique do I use. And when you do a question, the first thing you think of is, how is an outcome generated? Is it generated by selecting one item from different groups of items? If that's the way it's done, it's going to be multiplication rule. Are you selecting many items from one group of objects? Then you're talking about either a permutation or a combination. If the order of the outcome results in a different outcome, it would be considered a permutation. If the order of the outcome it does not result in a new outcome, it would be considered a combination. But you have to start out here.